So welcome to today's video. This is my first video of the design patterns, where I'm just trying to code and learn how different design patterns work and what they are used for. I'll be putting all of the code into here, my repository, into my public repository, so that hopefully you will also take your time, go through it, maybe even code along. So okay, so let's start. The first thing I would like to look at is the factory method, because it's the first in the list. And I've nothing prepared. None of these videos will be prepared beforehand unless I've already used the pattern. So I hope that you just please stay patient and let's learn along. Let's learn together. If there's anything you still don't understand, or if there's anything you find I said wrong, or if there's anything that could make the code better, please make sure to comment. I'll definitely look at it and reply to you. Alright, so abstract factory. The idea is that you produce families of related objects without specifying their concrete classes. So I'm also looking at Refactoring Guru. This is a great website to learn about these design patterns. So our problem is, let's say we're creating furniture shop, and the code consists of classes that represent a family of related products like chair, sofa, coffee table. So all of these are furnitures from the shop. Several variants of this family, for example, products, all of these products have variants as well. So there's a variant for modern, Victorian, or Art Deco. Okay. So we need a way to create individual furniture objects so that they match other objects of the same family. Customers get quite mad when they receive non-matching furniture. Okay. Fair enough. I mean, okay, so you have multiple objects and they are related. That's the main part of this. It's like a critical keyword. Yeah, that's the keyword for this problem. And the related products also have variants. So let's say that you've got different types of buildings. So you can have a family building, you can have a an apartment complex, or you can also have I don't know, some kind of a farm. Let's say that's like a farm, and then you can have different variants of those. So let's say one variant is Cyberpunk 2077. The other one could be, I don't know, medieval, or something like that. I'm trying to come up with a different example that also matches this problem. So okay, I think we understood that. We need to create individual furniture objects so that they match other objects of the same family. Customers get quite mad when they receive non-matching furniture. There is some chairs like last week, but I guess I need sofa too. Does not look right. Okay. You don't want to change existing code when adding new products or families of products to the program. Furniture vendors update their catalogs very often, and you wouldn't want to change the core code each time it happens. Okay, so I think we could use we could try using my example, because that's pretty similar. Let's start a PyCharm. Okay. And let's make a new project. I mean, I should probably pull from here. So yeah, this code, this entire repository might be in Python. I'm also considering using other languages, maybe Java, maybe C++, just to show how it would be done in other kinds of languages, So, okay, let's make a new project, and actually let's close project. And what we can do is get from VCS, and we can just go back to the code and just copy this. I think that would work. I believe so. Clone. Yeah. Alright, that works. Great. So, I really like how PyCharm also shows the markdown thingies. Yeah, okay, that works. That's beautiful. Okay. So let's make a new directory. Call it. I believe this is a creational. New directory here. Name it factory. And in here, abstract factory. I feel like I've read about abstract factor from someone who's not in the Gang of Four, but anyways, they had a no, that was different. It was a completely different thing. Never mind. Alright, so let's start by making main. Yeah, absolutely add it. Can we make a sample main? Oh, okay. Let's use OpenAI. I know it's something like if name is equal to __ main. Yeah, then you can run this. But this might be useful as well. Alright, so let's make this. So we make an interface for all of our, let's say, houses. So, okay, Python file, and this one will be family house. Family house, like this. Of course, add it. family house. Yeah, okay. This will be the family house class. And it's what should it have? What should it have? Maybe has gardens. Has garden and maybe you could have a dog. Okay. So define as garden, return true, just make it like that, and define pet dog, and then we go like, okay, yeah. This should be an interface, so let's remove this. Let's just make a pass in here. I wonder if we can do at interface. No. I remember we can do like abstract. No. They did it. They did it in the design patterns. Wait, this one is TypeScript. Right. Where am I? There we go. Python. And if you look here at the usage in Python, it actually shows us the code. Yeah, from future import annotations. That's probably where they got it. Okay, so let's do that. From future imports. Your source code contains future imports. You like to enable code compatibility inspection? Sure. Oh. I have no clue what I just clicked on. It's very early morning. I guess check for compatibility with Python versions. Wait, what? Excuse me. Python. Imports the form from future imports are called future statements. These are special case. The Python compiler to allow the use of new Python features in modules containing the future statement before the release in which the feature becomes standard. Oh, so those annotations are now standard. Okay. While these feature statements are given additional special meaning by the Python compiler, they are still executed like any other import statement, and the feature exists and is handled by the import system the same way any other Python module would be. This design serves three purposes. Avoid confusing existing tools, document when incompatible changes were introduced, to ensure that future statements run under release prior to 1.2.1, at least the other runtime exceptions. Okay. Guess we can just go like as we are. Annotations. So can we do that? Oops. I have to switch to English. Okay, apps. I can't do this here. What can I do this here? Abstract. No, wait, it's lowercase. Abstract method. Excuse me, it doesn't know what it is. Oh, it's from ABC. I thought that it's in annotations. What's the point of putting annotations in them? Annotations. There's like they import it, but never use it. Maybe it works for this one. Whatever. From ABC. No, I wanted to delete you. Import ABC. What What else can we put in abstract method? Can we do interface? No. Just what about okay? Just abstract method. Let's make this an abstract method. Alright. Let's not look at that. Let's look at this. So at abstract method. Can I do like abstract class method? Okay, there's quite a few things that I've never seen before in my life. This will be fun. Alright, so first thing the abstract factor pattern suggests is to explicitly declare interfaces for each distinct product of the family. Okay, so we've got the family house. Let's make an apartment complex. Okay. Okay. And in here we can import the same stuff. I'm not sure what the ABC does. Then ABC. Abstract base class. Oh! This module provides infrastructure for defining abstract base classes. See the pep for this. For why this was added to Python. The collections module has some concrete classes to derive from ABCs. They can, of course, be further derived in addition. The collections.abc submodule has some ABCs that can be used to test whether a class or instance provides a particular interface. For example, if it is a hash table or if it is a mapping. Okay. Okay. Note that the type of ABC is still ABC meta, therefore inheriting from ABC requires the usual precautions regarding meta class usage. Multiple inheritance may lead to meta class conflicts. One may also define an abstract base class by passing the meta class keyword and using ABC meta directly, for example. Okay. There's a lot to read in here, but let's just focus on what we're doing right now. Okay, so class apartment complex, and it shall have okay, let's get number or get apartments number. Okay. And pass. And make this an abstract method. And another abstract method. And let's say has tenants as and let's enter here. Alright, okay. So those could be our two interfaces for the beginning. Okay. Let's make another directory for this. So interfaces and let's make concrete classes or implementations. Concretes. Okay. And in here let's make what do we say? Cyberpunk. So cyberpunk. Just for this example, I think it's fine to have a one file for cyberpunk where we define both the apartment complex and the family house, just so we don't have like ×2 of everything. Alright, so we have a class, that's the cyberpunk family house. Don't forget to import from. Can I do /? Nope. From oh, okay. I wonder how, where this will look. I mean, this sees all the way like this is where what it sees right here, but I believe actually what happens when you run the code, it'll be more like actually in here in the abstract. So if I do concrete dot no, not concretes, interfaces dot family house. Sorry, I always mess that up. Let's import a family house, and then here we can do family house. Right, so now it knows where it is. I am not completely sure about this. So can I do /? Interfaces? No. You know what? Let's try it this way first, just because it doesn't show as a problem. Interfaces the apartment complex, import family. No, family house. Import that. Like this is a huge problem because what happens if I have a bigger project? That'll be like extremely painful to import at that point. But for here, I'll just keep it as it is. So I'll look into this. I'll look into all of this. We want apartment complex, import apartment complex. Right, so we're making the family house. So, right, let's Control O. We can implement all of these. 2 spaces, don't forget about those. Pet dog, let's just, when this happens, just print out okay. Let's say in Cyberpunk the dogs have robotic, like they have robotic modifications, so maybe it has like a radio and okay, I'm sorry duck people, maybe it has a radio and it's like throat or whatever, and when it's happy and feels like this, then it's gonna like play music, plays music. We can say it's a robotic dog, or that it's like a modified dog. Sounds really bad. I'm sorry guys. I'm sorry everyone. Alright. So has garden return false like this. Cyberpunk probably will have no gardens. Okay. Okay. Next class. Class. And let's make cyberpunk apartment complex. Like this. And yeah, this needs 2 spaces. I believe that's the problem. That's up to me. Alright, yeah. Okay. Let's enter in here. Get apartments number. I mean, to be fair, an apartment complex will probably have. It will probably have an init method with the apartments number, let's say, and solve the apartment number equals to apartments number, like that. So yeah. So now in here we will have to implement that. We won't actually, but let's say it just returns solve the apartments number. Yeah, return. Okay. Has tenants. Well, always will have. Or you know what? We can also add another function to here that add tenant and self.tenants number plus equals 1, or we can remove tenant self tenants number minus equals 1. Oops. Minus equals 1, and let's say that this will be 0. Okay. Let's reformat. Okay. So that's added a bunch of code. The dog plays music, of course. We have no garden in Cyberpunk. Get apartment number. Just return that. Has tenants. Return true if self.tenants number higher than 0. Oops, higher than 0. Else false. Like that. That's how you define an if statement in one line. Alright. Like, looking at the code, this is pretty much like, yeah, you don't need to do this. This makes like no sense. For the apartment complex. But let's just keep it. And move on. So let's make Kiwi medieval file. Okay. Where we will import all of these. And then make the classes just like they are made here. Oops, I did not mean to do. Oh my gosh. Oops. Stop. Okay. Here, and instead of cyberpunk, we'll do medieval like this. By the way, yeah, this in PyCharm, if you alt click, you can select multiple lines or multiple spots at once. Very useful, sorry. The dog doesn't play music if it's a medieval dog. It's just gonna be the dog works happily. Has garden is always gonna be true in here. So, okay. For the medieval apartment complex, okay. Here we will change the functionality of edit control O again, by the way, of add tenant, and so the super has the plus, and we will just do a check if so the tenant's number is below I don't know, like let's say that the apartment complexes in medieval times were small. Pretty much everyone had their house or they traveled, so they would stay at like a barn or something like that. I'm not sure what it's called, but like, you know, I'm thinking like Skyrim kind of type. Because I believe in there it was pretty much everyone had, let's say everyone has their own home, or they're staying at like a barn or something like that. So the maximum number of tenants of that would be, I don't know, 5. If it's below 5, yeah, if it's below 5, then we can add. Otherwise it's not going to do anything. Now there's a problem with this. Does not support this syntax. Super should have arguments in Python 2. South. Like that. Okay. Interesting. I should not have used that Python compat setting. I'm gonna have to gonna have to change that back. Compatibility inspection recommended. What's it? Okay, what is that? What am I looking at? Appearance, behavior, notifications. Oh, that's okay. So how do I remove that though? Whatever. Let's just keep it this way. And let's just move on. Alright, so now we have some concrete implementations of our classes, of our interfaces. So, sorry, I needed to drink some tea. You can make all variants of products follow those interfaces. For example, all chair variants can implement the chair interface, all coffee tables table variants can implement the coffee table interface, and so on. The next move is to declare the abstract factory, an interface with a list of creation methods for all products that are part of the product family. For example, create chair, create sofa, and create coffee table. These methods must return abstract product types represented by the interfaces we extracted previously. Chair, sofa, coffee table, and so on. Okay, so create coffee table, create sofa. Victorian furniture fact. Okay, so then you make. Okay, let's divide this yet again, and let's add products, or not products, buildings. In here we put the 3-factor. Yeah. Okay, so these will be the buildings. And then we need the factories. Factories. It's already getting a little bit complicated, in my opinion. Right, let's add a building factory. Oh my goodness. Sorry, I'm used to a different keyboard setup. Building factory. Okay. Yes, add it. Let's make a class building factory. And it'll have functions for create apartment complex and family house. Create apartment complex as create family house. This. I don't think we need to add anything much to this. Maybe just import these two, so the same way that it was done in here. We will include them like that. And this will on base return the apartment complex. No, okay. It just knows that it returns that. So pass. Wait. Like this, I'm gonna define that it knows that it returns an abstract type of apartment complex. And same for this, family house. Okay, again, let's read it again. Make an abstract factory, which will be an interface with a list of creation methods. Right here. And these methods must return abstract product types represented by the interfaces we extracted previously. Alright. So it knows that it returns this, and also we return a new instance of this. Abstract product. Okay. Okay, let's add a tenants. Swap and tenants and return family house like this. Okay. So it returns an abstract type, product type. I mean, it's not specifically said that it actually should return the abstract type, so I think it's fine if I keep it like this. It just needs the return value. It just needs to know what the return value is going to be. So we're gonna add a interface in here as well, refactor, and a concrete like this. New Python file. Let's make a cyberpunk. Yeah, like this. Cyberpunk. Curse add. Then here, let's make a devo file. Okay. So, alright, okay. This is what we've got. From operational factory abstract factories and interface import building factory and then class cyberpunk building factory inherits from did we call it? Yeah, we did. Interface building factory import building factory and here. We implement all of these. And okay, so here we do the concretes where we return an apartment complex with tenants, but we are not doing the interfaces in here. We're looking at the concretes, so concretes the cyberpunk and same in here, concretes dot cyberpunk. I don't know, that was my bad. It should be in here. I kind of can't read that because it's blocked by these errors thingies. I wish I could remove these from the top right somehow. Would be very nice. Whatever, let's put it on full screen for now. And here we want concrete, cyberpunk, apartment complex. And it's not gonna be alright, yeah, no. Import cyberpunk apartment complex and cyberpunk family house. Alright, so this is gonna be cyberpunk apartment complex, and this is gonna return cyberpunk family house. Oops. Okay. Like this. Should be fine. Space in here. Wait. Okay. Like I'm saying, this is too long. Okay, so Victorian Furniture Factory. That's one factory done. Now we want to do the other one. I want to do the medieval factory and building concrete, medieval, and okay, what's the problem here? Yeah, okay, so instead of like doing this one by one, you can just do boop boop, and then cyberpunk. You could also do Control R, I believe, yeah. Huge. So here we do cyberpunk and we replace it to be medieval. Like that. Okay. Buildings concrete. Wait, what is the problem here? Medieval apartment complex? Oh. I made a little typo in there. Whoops. Well, let's fix that. No, I wanted to press X in here. Refactor, rename to medieval. I'm pretty sure this is how you write it. No. I actually wrote it right. Never mind. Don't mind me. Okay. Then it's my bad. R deal. Yes. Okay. That's good. And how about the product variants? For each variant of a product family, we create a separate factory class based on the abstract factory interface. A factory is a class that returns products of a particular kind. For example, the modern furniture factory can only create modern chair, modern sofa. Client code has to work with both factories and products via their respective abstract interfaces. This lets you change the type of a factory that you pass to the client code, as well as the product variant that the client code receives, without breaking the actual client code. Give me a chair. I have a name, you know. I don't care. Your factory sold it to me. True. Client shouldn't care about the concrete class of the factory it works with. So the client wants a factory to produce a chair. The client doesn't have to be aware of the factory's class, nor does it matter what kind of chair it gets. Whether it's a modern model or a Victorian style chair, the client must treat all chairs in the same manner, using the abstract chair interface. With this approach, the only thing that the client knows about the chair is that it implements the sit-on method in some way. Also, whichever variant of the chair is returned, it'll always match the type of sofa or coffee table produced by the same factory object. So, okay. I mean, for my example here, we can just say that this is for some kind of a game where you build cities, and you can pick different themes. So one theme is that you want to go for a cyberpunk city. The other one is that you want to go for a medieval city. I like that. So the client pretty much only has to know what a certain type of houses do. As long as he picks like whichever theme, he doesn't have to know the name of the classes and like everything like that. All he needed to ever do was just pick the theme once, I guess. Or it doesn't matter what kind of chair it gets. With this approach, the only thing that the client knows about the chair is that it implements the sit-on method in some way. Also, whichever variant of the chair is returned, it'll always match the type of sofa or coffee table produced by the same factory object. There's one more thing left to clarify. If the client is only exposed to the abstract interfaces, what creates the actual factory objects? Usually the application creates a concrete factory object at the initialization stage. Yeah, that's what I meant with the client first picks whichever theme he wants, I guess. Just before that, the app must select the factory type depending on the configuration or the environment settings. Yeah, so in here, let's say that this is what the client sees. So all he knows is mainly the top in here, and then this is like where he picks stuff, and this is where he works with the stuff, I guess. Or like this is where he picks the settings. That's what I meant. That's where we pick the settings. Right, so the theme shall be medieval. We like medieval a lot. Okay, so let's look at this structure. The client sees the abstract factory. He has an abstract factory in here, so okay. From creational factory abstract interface of factories. We want interfaces, or the interface, building factory import, the only thing that's in there, building factory, pretty much. And here we will declare that we have a factory that's equal to the building factory, like that. Okay. Okay, I see. So that's the initialization that we do. So let's just keep it simple and just do like a basic if statement in here. So we just do okay. Let's define the factory. Let's define the factory as the building factory, like this. I think it's fine. Is there a problem in here? Python version 2 does not support annotations. Really? That's interesting. It's none in the beginning. Okay, you know what? Huh. Interesting. Interesting. But we all know what we're trying to do. Let's keep it like this. I'm gonna turn off the highlight later because we're not using 2.7. So alright. So this will be the initialization state. So factory is equal to, right here we can do it, is equal to and we have to import medieval. Can we? No. Okay, so we have to import this from here, from creational factory abstract factories and concretes and import everything. And it's equal to, let's say, cyber. Okay, so it doesn't concrete the everything. Everything. Can I do it like this? Import. No. Okay. factories, concretes, import everything from creation, this, the everything, new. Okay. Alright, I'll just do it one by one. From factory abstract factories, concretes, the medieval import, everything from traditional factory abstract factories, concretes, cyberpunk, import everything. So can I do that the building factory will be equal to the medieval building factory? You know what? Cyberpunk building factory, so it's more exact. Medieval building factory, like this. And we'll do this if a theme is medieval, else it'll be just the cyberpunk building factory if it's anything else. This is just a basic example. So yeah, so that picks the factory that we want. So let's say that the client clicked on that they want to play with the theme of medieval. We go like, yeah, okay. Here's your factory. He only knows, or he only should know, that it is like a building factory, and it just can't make those buildings. So let's make a complex. I think that's, or let's just make a normal house. First house is equal to factory dot create family house, and then we can attempt printing the type of first house, and we can try printing or not printing, but we can do first house dot pet dog and see what exactly happens. I think it's gonna error on the import statements, to be honest. Let's run this. Yeah. Wait. It says syntax. Oh, that's just syntax warning. Yeah, the dog barks happily. And if we do cyberpunk, and we play it, the dog plays music. Yeah. Okay. That's cool. So I think the concept of making a theme for a game, or like making a game that has the option to change the main theme, is a good example. Another similar idea might be making a, again, I'm thinking about games in here a lot, but another idea wouldn't be just a theme, but you could switch it using the level. So okay, the levels could have different themes. Let's see, if we look at Hades 2, some pictures. There are a few enemies that are kind of recurring, I guess, that could, like, okay, there's a different theme for this level, or like for this floor. Yeah, that's the word. For a floor, you have a different theme for the enemies. I believe that's still the same for but you get the idea. Like you could have enemies that are maybe represented by a similar named or like a similar interface. So it could have like a move method or something like that. But let's say that okay, so let's say that we have an enemy, right? He's very evil. He's very mad. He wants to kill us. In the first floor, let's say that all he can do is just stay still. He doesn't move or anything like that. And if the player, let's do like a circle like that. If the player gets too close, that's when the enemy starts attacking. But I feel like with this factory, you can make it so if we go to the second floor or level, or if the theme changes, then this same interfaced enemy could have different looks because we just used an interface, so it can have different look. It could look differently completely. Both of these could have a move method where this one just doesn't move at all. But this one already has some logic, so let's say that he can move, or that his attack will be that if the player is in range, in the correct range again, yeah, let's say that the player is here now, then the enemy is going to just dash through the player, or like attempt to dash through the player. I did that with the wrong color, but you get the idea. I think this is a pretty powerful design pattern already. So yeah, that was the abstract factory method. I hope that you got something from this, that it was understandable. And if you have any questions whatsoever, or any anything that you didn't really agree with, or anything that you would like to add, you could always comment. If you liked the video, please give me a like. And if you want to see more content like this, also consider subscribing. And yeah, I'll see you in the next one. Thank you.